Well, welcome back to Wickerson Studios. Going to continue right along with what I was working with, building NumPy arrays. We were up to a two-dimensional array from two lists, and we're just going to continue through with that. I was talking about things you might want to do and things you don't want to do. What we want to avoid is for loops when dealing with NumPy arrays. There was the issue of not working in Grasshopper Canvas with the AR list to tree. So you have to solve that with entwine, and you have to solve that without putting your array list to certain. You have to make sure you grab the certain list number whenever you're using it. And I sometimes type that in under after the array information here. Anyway, I thought what I'd do is while we were on break is just entice you to why this is a powerful tool. And you can see right here that the data visualization we were doing before, which was pretty boring, it was top down, but it was showing the complexities of that. It doesn't take much to throw this data and information into the vertical. And if you do that, you can start to think about grabbing your array's list lengths. And you could do this back in Visual Studio Code, but I just don't care to do that. I'd rather come out and start building geometries, and what I thought was floor plans would be the most interesting things to do, and cell patterns. And once you have those, we'll start with the simplest one. You can simply step through those patterns, and you see right here that I have the 1, the 2, the 3, and I'll just do zoom extends all so we can actually see what's going on. Oops, zoom extends all. Each pattern as we go through the triangles and the polygons, which are hexagons. And you can create more of this if you want, but that's just a nice thinking about visualizations. And then if you start thinking of these as geometries, you can drive all of those by random generations as we pop through here on a gene pool. And when we get into pandas, we're going to be driving this from Excel docs and SQL docs and CSV files and really doing some magic with this. So I'll just leave it all on, and you can choose what you want to do. But if you get a pattern that you actually like, say, and you just want to alter it a little bit, I actually like extending this pretty full, keeping one kind of in the middle, one pretty low, one pretty low, one high, and one in the middle. And you get this kind of strange pattern of what's lofted and moved. And you can think about these as floors to a building. So architecturally, you also could start to measure the volume and areas of these. So if we were to take these into something like, oh, I am recording. Okay. If we took these into surfaces, we could start using Galapagos with the gene pools and parameters to drive. So think of the numerical parameters you're doing to drive these areas to optimize things. Now, it's not going to build a building for you, but it might give you some nice kind of conceptual ideas of how you would build something. Very simple. All we're doing is moving from a 2D system up to a 3D system, even though we're still dealing with planes. You want to keep your geometries very light, and you certainly want to keep your scripts extremely light. Remember to take your cache memory and cache server off, and I think it's good practice just once in a while to clear your hops cache. So you don't want anything memorized, and if you're doing that well, then you'll see your data is updating. You can kind of troubleshoot in here as if you're in Jupyter Notebooks or IPython, but you can do it down here in the terminal window. So we're just going to continue right along. We are recording. I'm going to keep this data here. This is a nice getting into the data visualization. I might wrap that one into here, add to group. And that's probably enough to start. Data visualization is fun. I like to kind of tuck it in here and then, or maybe off to the side. Maybe I'll just start to pull the data visualization over here. It's a little clumsy with the wires, so that's why I like to pull it down so I can actually visualize it. But let's do something else. Let's get in here and think about what is happening before we have the series and the points. All we really need is this data from here to copy. And we'll do a quick copy and paste. We'll drag that down and we'll get ready for what we're going to build next. And as we build next, we won't need this 2D array. We'll substitute that in. We'll change the name of what we're doing, and we'll see what GitHub Copilot plans for us after. We'll just prime it with so it wants to create a three-dimensional array from 3 lists. So let's just take a look at that's actually what we want to do. I've got to get out of my pages, and that's exactly what we want to do. And I think it's kind of interesting that GitHub, I'm just following along with the tab and enter, which is a nice way to do it. Write it into a hops component. So we are going to jump in here, and this is as fast as it goes, 3D array. Let's take the name, let's take the description, let's take it off so we can save it anytime. And one little practice I like to do to just keep my head as simple as possible is get ready for this script over here in Grasshopper without the data visualization. And you can just clear your head as to what's happening. So description is going to want an icon. You can put icons in and you'll see that they show examples of that. I think I took it off, but no, there it is. There's a point at PNG icon. You can make all those if you want and spend all your time with that. But like I said, I don't get paid to do any of this stuff. This is all open source. Well, pretty much open source. I have it on my GitHub most of the time, but lately I've been trying to find out the demographics of what, and analytics on Google Analytics, what people like. So I keep my prices incredibly low. Please have a look at Wickerson Studios, www.wickersonstudios.com, and see if there's any direction. I have learned people want me to go live at Greenwich Mean Time at about 3 p.m. where I am, but 9 p.m. At Greenwich Mean Time. And they're interested in the most basic or most advanced. Those are what I've polled, and I've gotten a few dozen that have responded to that. And I've got, a few hundred people that are actually buying the packages and bundles, mostly buying the big bundle that's at a low price to get all my research. These ones are going to be a little more specific as I bring them out. As to the GH file that fits with the app as it develops, and you're seeing how this happens tied to the videos in YouTube. So I'm trying to allow for a better YouTube tutorial. So enough said there. Let's jump in here, grab the inputs. The inputs are going to grab me a list, and I like this is improving now, so you can see that it's actually being GH hops param access typed in correctly. And that's just like being back in the Python or C# node and having this set list. And I don't take anything past item and list into trees because I have to solve that tree back in the Grasshopper until something develops at McNeil's to solve that. And maybe that'll happen in a year's time or something like that. Or we'll just go right into Grasshopper 2.0 and see what's happening. So we're bringing back a list, and probably three, because we've got to entwine those afterwards. I'm just going to bring these out here, and I think that will get us started. Hang on a second. Develop it, hops. Yeah, it's in the right location. I just have to watch my indices. It's going to bring in those three lists. It would be nice if it brought them in as a list. I might have it do that, but since it defaulted to that, that's fine. There you go. You get your list, 1, 2, 3. There's your array to list, and you'll see that output is returning the first list in the data tree, or first list in the array of lists, or first list in the array, however you want to say it. And that should be enough to do it. And that's basically it. It's not more difficult than that. You want to run your script with F5, grab your IP address. It's this simple to build these yourself. However, I don't think a lot of people want to tediously debug and work through this stuff, and I totally get that. I'm going to use only the hops node unless it's something I'm familiar with. I will double click, I will pop it in, I will /, and I will take the name of Numpy 3D array and pop it in here. And with any luck, we'll be able to pull a list. And at this point, I might go up and get into the not 4x4, we'll deal with 3x3 arrays still. We'll change this in time. Let's jump in here and do an edit. Let's go up to 9 units and let's hit OK, and let's drag that down, and let's also add to our exploding tree, which will give us a little more information here. It's a little clumsy, but just do this in preparation. It's like kind of hard coding, which they do. Drop these in here. Give yourself a nice fancy randomized, and flatten your data again so you can bring it in as a list. I think it is a list. No, it's a tree, so you have to flatten it. And you'll bring that in as list 1, list 1, list 2, and list 3. If I actually could get my fingers to work. I'm going to drag this down here. We're going to entwine that, which is kind of redundant, but just keeping this type of order of arrays to data trees and working with lists is kind of essential for wrapping your head around it. We'll pull this down here, and I've got this I like the snapping tools. We've got enough information to start, and there we go. I will left click. I will take my call command, which is numpy. Okay, I will right click here. I will change hops to that to bypass the icon. I'm very repetitive when I talk through things. And over here, I'm going to drop it in as the call so you can set it up. And the reason is when you go into these pages, sometimes when you go in, you have to reconnect these to make it work. When you open up a file after, depending on the order of how you open Visual Studio and Amazon, Anaconda, and how you opened Rhino. But a lot of cases, you have to drag this down, drag and drop a hops node. You have to set the path to exactly what was going on here. So you have to come over here and grab this. You will have to do this each time. You will have to /, and you will have to go back over and grab the name in the script. And you'll pop it in there, and then you'll have to get it up and running, and you have to hook it up again. And that's a pain in the butt. And actually, maybe I'll leave it there, because that's just what you have to do periodically to make this work. And I'm going to use that as a little sample there. And that's frustrating. We're not going to build any data visualization with this, which could be fun. We've got some numbers here. We can see how it complicates. Let's take our simple geometries here, right here. Let's copy this, and let's just take the data into the X component and take the data into the, that's the plane, and we'll take the data into the radii. And then you can see the visualization, which is pretty, simple enough. We want to only see what we're clicking on. You can see the complexities of that. Things get really hairy and crazy fast enough. But it's the level of control that you want to do. If you start to numerically pull this out and do things with different ranges, we should be able to pull some order here just by playing with this. And if you understand multidimensional number sliders and ranges, you're getting some pretty nice geometries to start with. And there's some point grids on there as well. So I'll just leave it simply like that. That's a good example of, but we need to change it as well. This is a two-dimensional array from three lists. Okay. Three lists, and that's simply what it is. So not too hard. Yeah, that's it. And what we may end up doing is just leave this open for interpretation as we go. So I'm going to change this as we get higher into what's happening, just an n-dimensional array from three lists. Be very specific from that. So it's a big roundabout way to do what you could do very fast in Grasshopper, but just think about the control level of this as you go and the necessity for this. The Y coordinate here, I like to do a relay, disconnect the relay, and then pull that out. Let's see what now it's brought it back down. You could always bring this data into here as well. So that's kind of nice. We'll go into the Z coordinate if you want. I don't think I'm going to bother with it doing anything. And you can see the point system that's actually driving it, which is kind of nice. And then from that, you can start thinking of your geometries. Don't get caught up, and keep in mind, take your cache off. So when you're running this, you can see this, but don't get caught up in the geometries, in my opinion, unless you want to become super proficient at that. It's kind of like going into the documentation for Rhino Common and Rhino, what is it called? Rhino syntax, script syntax. But I just want to deal with numbers and then leave it possible for what I would do with that numbers. And I don't see any chance, any necessity to move that outside of that. You can see here with the decimals coming after, the arrays running different than the lists. And that's exactly what's happening here. And I'm actually typing out the class list, the type of class, and I'm typing out the type here. Obviously, Grasshopper reads lists. It doesn't read NumPy arrays, and that's where we have to get around this and twine. And you'll figure that out as we go. So I think that's enough for now. It's a short little video. Let's just guess at, close this up and clear, just get it ready for the next one. Let's see what, and what's nice is you can start to have double square parentheses here. Sorry, to deviate, just pick particular numbers out if you want. And you can use that and have that as an output on these nodes that will drive something as like a point attractor or something like that. It can get really complicated very fast. So now it wants a four-dimensional display, but I'm not going to do that. I'm going to talk about, what am I going to talk about? Returns data shape. We're going to get into a data shape. It returns a tuple indicating the size of the array in each dimension, and data type is an object describing the data type of the array. So I might get in there and do something. Let me see if I'm doing that farther down. Array to list, scaling. I think what I'm going to do is jump right into scaling data as we go, which is multiplying the data, and we'll see how we end up doing that. a little later on, but I think I'm going to bypass the information. It might be good to type this in here just so you have it because it is out of the textbook. So I'm just going to say data shape is let's say returns a tuple indicating the size of the array dimensions, and data typing introduces that. I just think that's good information to have in there, and you can test all your data as you go a little farther on if that's something you want to do in the terminal window as we kind of process things. But here's something also. Do not, it's another tip, do not import with asterisks from NumPy. Import because, and why is that? It will overwrite Python functions, conflicts, okay? Conflicts, and this is just something important to know with Python, with things like data shape and data type and data, well, a whole bunch of things, and dimension. So I'm just going to leave it at that as a little warning. And then we're going to go right into something interesting on the next area, which is going to be scaling a 3D, n dimensional array. And that's what we're going to get into, and we're going to write that into a hops component. And we'll do that in the next one and see how that goes. Well, thanks very much for watching. Sorry that drew on a little bit, but we will just keep going as we build this app. It's getting kind of juicy. It's getting a little bigger. We'll keep filing through. We've got this started with a couple here. You've got your key tips to how to load it. We've got our warnings about the tree information and using entwine. And we can start driving geometries from over in Visual Studio using NumPy. I hope this actually makes a lot of sense to people, and I hope people end up using this to make more complex and interesting creative scripts. So we're going to get into array and dimensional scaling in a minute. We will stop recording.